In this tutorial, I will demonstrate how we can install DHCP server on a Linux using CentOS 8. The same steps can be taken to install DHCP server on a Red Hat Enterprise operating system. Before installing the DHCP server, we need to make sure this operating system is up to date. Let's go ahead and do that. I'm going to log into the root. Then I will be running yum update. I have already installed the yum updates, but if you would like to do that on your system, the command is yum update. Next, we will install the DHCP server. To install the DHCP server package, type yum install dhcpd.service. Press enter. This will download the DHCP server package. Now we have installed the DHCP server, we will update the configuration file. To do that, I'm going to use the nano to edit that file, but you can use any text editor. So the file is located under etc. dhcpd.conf. And when you open that file, you will have some basic information at the top, and the rest of the file should be empty. Now in this file, it stores information about your DHCP server. Basically, all the configuration that needed to run your DHCP server will be stored in here. There are two types of statements that we can add to this file. One is called parameters, the other one called declarations. Parameters states how to perform a task, whether to perform the task or what network configuration option needs to send to the client. Declarations describe the topology of the network, describe the clients, provide the addresses for the clients, as well as apply group or other policy parameters. Let's start with DHCP server basic options configurations by adding the following parameters. I'm going to briefly go over what are these lines means. Basically, the option domain name is the domain name of our system, our network, which is sanuja.local. The default lease time you can set to any time you like. This is the time that I decided to set, and then the maximum lease time is the same thing. And the term authoritative here is a keyword. This basically means this particular DHCP server is the primary DHCP server for the network. When a device requests for a DHCP IP address, if there are multiple DHCP servers, the authoritative DHCP server should respond first. If there are multiple DHCP servers with authoritative added to it, whichever the authoritative server that first sees that device will hand in the IP address for that particular device. So this authoritative term in this configuration file, we'll make it so that this will be the primary DHCP server for the network. Next thing we need to do is we need to declare the subnet so that it knows what kind of IP addresses that needed to be given. So to do that, I'm going to just type a comment. So it will be subnet. I'm going to use 192.168.1.0. And the next mask for that is 255.255.255.0. And we're going to tab into this middle so that within that category, so it's easy to read. So you're going to do option routers 2.168.1.3. Now this option router is my RAS that has been installed on the Windows Server. So I have the RAS installed there, and my Windows Server RAS has the IP address of 192.168.1.3. So that's why I'm pointing back at it. If you want to know how to install a RAS, there's a video that I have done on my YouTube. You can check that out. And then the next thing we're gonna do, we're gonna use option subnet mask. So again, it's gonna be 255.255.0. And the next thing we're gonna do is option domain search. We're gonna go local and option offset. Range 2. Now I will give you a quick brief explanation of what I just did, just like I did before. So the subnet is 192.168.1.0, which is the network address, and then the net mask is the 255.255.255.0. Then we have a couple of options. So one of them called the option router, which is the DNS service and the routing service that I have set it up on the Windows Server. So this is my Windows Server IP address 192.168.1.3. This is because I have my router or RAS is installed on the Windows Server. If you don't have that, you can just simply point this back at to your router in whichever the network you are in. And this is the subnet for that, which is going to be 255.255.255.0, the same one as this one. And the option domain search is my ADDS domain, which I have installed as sanuja.local, which you don't need to have, but because I have it, I enter that option. The option time offset is the offset that you need to set where this DHCP timing is done. So in this case, negative 18,000 basically means Eastern Standard Times. That because of I'm setting this to Ottawa, Canada. So that in Ottawa, Canada, the time is negative 1800 in seconds for the the Eastern Standard Time offset. You can Google search what offset is in your region, and you can set that to whatever the offset that needed to be set. And this is the range of DHCP IP addresses that will be handed out by this DHCP server. This is a very good example of how we can also allocate a certain IPs for static IPs, because you can see I didn't start at 192.168.1.2 or something like that. Instead, I started 1.11. This is because I'm using bunch of static IP addresses in my servers. For example, 192.168.1.3 is my server IP address for the Windows server, and 192.168.1.5 is another one, so on and so forth. So notice that I make sure that static IPs we use for servers from 192.168.1.2 to 192.168.1.10 are outside the DHCP IP range. Otherwise, this might create a conflict if the DHCP server is handing over IP addresses to devices where we already have static IP addresses. You must always make sure that your static IP addresses are removed from this DHCP pool. Now we have created our DHCP configuration file. We can save this file and exit it and make sure there are no spelling errors or any errors in here. And you can reopen and make sure it's still there. And then what we're going to do, we're going to restart the DHCP server. To do that, I'm going to go systemctl restart dhcpd. Now it looks like I have made an error. So that's why I got this error message saying there's an error message, it is failed to start. So let's go and fix it. This is a good learning experience. So this is a really good learning experience. So what I did actually, I got an error message saying it cannot run the DHCP file, and check the journal CTL. So I checked the journal CTL and it gives a really good explanation what's wrong with my file. Basically saying the subnet declaration is not given on the interface that needed to be used, and therefore that is creating an error. So let's see how we can fix it. The first thing we need to make sure that we have a static IP address on this server. Currently I have a DHCP IP address that been obtained from my different DHCP server, which is bad. So that's one of the reasons this is happening. So let's go ahead and fix that. To fix that, I'm going to go into network configuration, go to wired settings, and in here I'm going from DHCP to manual, and I'm going to give 192.168.1. Let's say 6. 255.255.255.0, and then 192.168.1.3, which is my RAS server, and my DNS is going to be 192.168.1.3 as well. And this is just a static IP address I pick outside that the DHCP pool that we have created, and I'm going to click apply and then close the window. And this particular VM, I also need to make sure that in the settings, this NAT configuration on the network adapter is now set back to the internal network. In this case, it's Sanuja lab_network. So I'm going to make sure we are in the same network and press OK. And now if you restart the DHCP, it should restart with no errors on it. Also, I should mention this is a really good learning experience. If you get these error messages, it will tell you up here, for example, it will tell you that there's something wrong, check the journal CTL-XE. So what to do that, basically you enter journal CTL-XE, and that will give you the journal entry on what's went wrong. And in here, it clearly states what was wrong right here. And I use that information to fix the error. So now the DHCP is running and everything seems to be working. So this is a really great example of the system, operating system, coming back with an error message, and as a system administrator, you take the necessary steps to fix the issue based on the error message. Having said that, let's see if we can get a DHCP IP address to a Windows end client. So before we go ahead, I will also check systemctl status dhcpd. It'll give you the current status of our DHCP server, and it right here it shows us as running. So let's go ahead to our Windows device on the same network and see if it can obtain a DHCP IP address from this server. So I will test our DHCP server on our Linux system using a Windows 11 end device. So let's log in. Go to Control Panel. Go to Network and Internet. Network Sharing Center. Click on the Ethernet card. And on the interface pop-up window, go to Properties. Go to IPv4. Properties. And I'm going to set this to DHCP. And I will leave the rest with my server and click OK. And this particular VM is also in the same network as my Linux DHCP. Once you have configured that, you can close this window. You can go to Start menu, and I'm going to command prompt by typing cmd, and then I will enter ipconfig/all, and as we can see, the default gateway is 192.168.1.3. The DHCP server is 192.168.1.6, which is our Linux system. And the DNS server is pointing to the right place. And we have a DHCP IP address of 192.168.1.11. So the DHCP IPv4 showing as 192.168.1.11 is within the range of the DHCP pool that we set up on our Linux DHCP pool, the DHCP server. And the DHCP server is showing as 192.168.1.6. This proves that this particular Windows machine obtained its IP address from our new CentOS DHCP server. If you go back to our CentOS DHCP machine, and if you go ifconfig, and you can see the you can see the IP address for this CentOS machine. The static IP is 192.168.1.6. And if you look at the configuration file for our DHCP, it has a range from 192.168.1.11 to 192.168.1.100. And when you go to your Windows end device, in this case Windows 11, and when you look at the DHCP configuration, you can see that the DHCP server is 192.168.1.6, which proves this is getting the IP address from that Linux server. You can also test this by ipconfig, and you can go /release, and you can go and ipconfig/renew and press enter. What it's going to do, it's going to renew the IP lease from our DHCP server. Now if we go ipconfig/all, One moment. pconfig renew. There you go. So if you go ipconfig/all, yes, it did obtain an IP address. Again, it is 192.168.1.11, but it is a DHCP IP address, and it shows you can release and renew, so it's not static, and it works as it expected. And that's how you can configure a DHCP server inside a Linux system and obtain an IP address through DHCP onto an end device, in this case Windows 11 computer. In our future videos, we will look into some advanced configuration inside the dhcpd configuration file. But for now, you have a working DHCP server, and it is handing IP addresses to end devices. Have a nice day.